A to the square root of x. That's another good guess, but doesn't quite work.
Isn't it log base x of a?
Yes. This is not something I think you would be able to figure out unless you've seen this before, but this is what it's going to be, log base a of x. And this is how logs come in. Logs are the inverse of the inverse functions of exponential functions. They undo exponentials. Okay, so like let's look at
Can I ask a quick question?
Sure, go ahead.
Yeah, so when it says logs are the inverse function of exponent, then in the one above it, when it's f minus 1 to the x is x squared, wouldn't it be log x2?
No, because x squared, good question, x squared is not an exponential function. It's a
Oh, gotcha.
Yeah, but even though it has an exponent there, so that's why it's a really good question. This has an exponent, but this is known as a square function. An exponential function is one where you have the exponent equals the variable. The variable is the exponent. So really good question there. So logs are the way to undo an exponential function. All right. By the way, I should mention, have you guys ever heard about exponential functions before, like outside of a math class?
Yes, in economics.
Okay, like exponential growth.
Yeah, in science.
Growth and decay.
Growth and decay. Yeah, some of you maybe heard in the news, COVID-19. Some people, when they first talked about it, they talked about it having exponential growth. And when something grows exponentially, that means it grows really fast. So usually they're comparing it to like linear growth. We're used to linear meaning a line. So here's the way lines grow. An exponential looks like this. So if you carry this out pretty far, the difference between those two is really going to become large. And like you said, in economics, monetary growth, if you invest money at a certain rate, it's usually an exponential function. Okay, or if you talk about bacteria growth or decay, then they often talk about exponential growth. So it's a very useful type of function. Now, how can you use logs then to help deal with exponential functions? Well, this is how logs are defined. They're defined in terms of the exponential. So log base a of x equals y. It means the same thing as a to the y equals x. So if I had, example, if I had like 2 to the x equals 5, that's equivalent to saying log base 2 of x equals 5. Or maybe a better example would be, let's say we did 2 to the third equals 8.
Doesn't that mean log 2 of 5 is equal to x?
Yes. Sorry. Yeah, that was not a good example. Let me give you this example is better. Okay. 2 to the third equals 8. Okay. That's equivalent to saying log base 2 of 8 equals 3. Now, where it comes in useful here is, so I'll give you another, let me give you another example so you can figure this out. Suppose I gave you log base 3 of 9. What does that equal?
2.
Yeah, let's say we have this and we just said this equals question mark. Then that would mean that 3 question mark equals 9. And that would be 3 squared equals 9. So the answer is 2. Log base 3 of 9 equals 2. So you can use logs to undo exponential functions. So so I'll give you an example of doing that. So if I had to solve 2 to the x minus 5 equals 3 for x, what I could do is I can take log